Hello students, let us read this question. Examine the consistency of the system of equations. So in this question we have given three equations and we need to check the consistency for the given system of equations. So for that we need to first write these equations in the form of ax equals to b, where all a, x and b are in the form of matrix. So let us first try to convert these equations in the form of matrix. So the given equations are 3x minus y minus 2z equals to 2, then 2y minus z equals to minus 1, 3x minus 5y equals to 3. If you try to convert this in the form of matrix, this will be 3 minus 1 minus 2. Then since for the second equation we don't have any x term, we can substitute 0 here, then minus then 2 and minus 1, then this will be 3 minus 5, and for the third term we don't have any z. For the third equation we don't have any z term, so we will write z equals to 0. So this is x y z, and this will be equal to our b, which is 2 minus 1 3, 2 minus 1 3. So we have written the system of equation in the term of matrix, where this is our matrix A, this is our matrix X, and this is our matrix B. Now the first thing that we need to check here is to find out the determinant. So since we have A, the determinant of A will be 3 times 2 into 0 minus of 5 or minus of minus 1 into minus 5. Then plus 1 times this will be 0 into 0 minus of, so this will be minus plus plus, so this will be, or we can say that this is minus of minus 1 into 3. Then this will be minus 2 times 0 into minus 5 minus of 2 into 3. So this will be 3 into 2 minus 0 is 0. Then minus 1 into minus 5 is plus 5. Plus 5 into minus 5 is minus 5. Then it will be 1 into 0 into 0 is 0. Then minus 1 into 3 is minus 3. Minus 3 into minus 1 is plus 3. So this is plus 3. Then next term is minus 2 times 0 into minus 5 is 0, minus of 2 into 3 is 6. So minus 2 into minus 6 will be plus 12. So this is minus 15 plus plus 3 into 12 is again 15. So our determinant comes out to be equal to 0. So since our determinant is equal to 0, we have to check, we have to find now adjoint of A times B. So first let us find out the adjoint of A. So our matrix A is nothing but 3 minus 1 minus 2, then 0, 2 minus 1, then 3 minus 5 and 0. This is our matrix A. Now in order to find out the adjoint of A, first we need to find out the cofactor matrix, and by taking the transpose of cofactor matrix we will get the adjoint of A. So for that, for cofactor matrix, first we need to find out the minors. So minors are calculated by ignoring the rows and columns corresponding to it and find the determinant of the rest of the matrix. So for M11, we will ignore the first row and first column elements, and the determinant will be 2 minus 1 minus 3 minus 5 0. So this is 2 into 0, which is 0, then minus of so this will be minus 5, because 0 minus of minus 1 into minus 5 is plus 5, and plus 5 into minus 5 will be minus 5. Sorry, plus 5 into minus 5 is minus 5. Then M12 will be equal to, so for this we have to ignore first row, second column. So this will be 0 minus 1 3 0. So this will be 3. Then M13 will be first row, third column. So this is 0, 2, 3, minus 5. This is minus 6. Then M21 will be second row, first column. So this is minus 1, minus 2, minus 5, 0. So this is 5 to the 10 and minus. So this will be minus 10. M22 will be second row, second column. So this is 3 minus 2, 3, 0. 3 minus 2, 3, 0. So this is plus 6. Then M23 will be equal to 2, 3 will be 3 minus 1, 3 minus 5. 3 minus 1, 3 minus 5. This will be minus 15 plus 3 is minus 12. M31 will be equal to third row, first column. So this is minus 1, minus 2, 2 minus 1. So this is 1, 1 plus 4, which is 5. Then M32 will be equal to third row, second column. 3 minus 2, 0 minus 1. 3 minus 2, 0 minus 1. So this will be minus 3 into 0. So it is minus 3. And M33 will be equal to third row, third column. So this is 3, 3 minus 1, 0 and 2. This is plus 6. Now the elements, we will calculate the elements of cofactor matrix, which are given by minus 1 raised to 1 plus 1 M11. So this will be minus 5. Then M12 will be minus 1 raised to 1 plus 2 M12. Now M12 is 3. Now minus 1 into 3 will be minus 5. Then A13 will be minus 1 raised to 1 plus 3 M13. Now M13 is minus 6. So minus 6 into 1 is minus 6. Then M21 will be minus 1 raised to 2 plus 1 M21. Now M21 is minus 10. Minus 10 into minus 1 will be plus 10. A22 will be minus 1 raised to 2 plus 2 M22. Now M22 is 6. So 6 into 1 will be 6. M23 will be minus 1 raised to 2 plus 3 M23. Now M23 is minus 12 and minus 12 into minus 1 is plus 12. Then A31 will be minus 1 raised to 3 plus 1 M31. M31 is 5, so this will be plus 5. A32 is minus 1 raised to 3 plus 2 M32. Now M32 is minus 3. Minus 3 into minus 1 will be plus 3. And A33 will be minus 1 raised to 3 plus 3 M33. M33 is 6, so this will be 6. So therefore we can say that our cofactor matrix of A will be minus 5, minus 3, minus 6, then 10, 6, 12, 5, 3, 6. So adjoint of A will be the transpose of cofactor A. The transpose means we need to replace the rows with columns. So this is minus 5, minus 3, minus 6, then 10, 6, 12, 5, 3, 6. So this is our adjoint of A. Now we need to calculate adjoint of A times B. So adjoint of A is minus 5, minus 3, minus 6, minus 5, minus 3, minus 6, then 10, 6, 12, 10, 6, 12, and 5, 3, 6, 5, 3, 6 times B is 2 minus 1, 3, 2 minus 1, 3. So let us calculate this. So this will be equal to minus 5 into 2, which is minus 10, plus 10 into minus 1 will be minus 10, plus 5 into 3 is 15. So this will be minus 10 plus 15. Then this will be minus 3 into 2 will be minus 6. Then 6 into minus 1 will be minus 6. Then 3 into 3 is 9. So this is plus 9. Minus 6 into 2 is minus 12. 12 into minus 1 is minus 12. And 6 into 3 is 18. So therefore we can say that adjoint of A times B comes out to be, now this is minus 20 plus 15, which is minus 5. Next element will be minus 6 will be minus 12. Minus 12 plus 9 is minus 3. Then minus 12 is minus 24. Minus 24 plus 18 will be minus 6. So this is our adjoint of A into B. Now we can see that this is not equal to a null matrix. So we can say that since determinant of A is equal to 0 and adjoint of A times B is not equal to 0, we can say that the given system of equation, therefore the given system of equations are inconsistent, and we can say that therefore the system of equations has no solution. So since the equations are inconsistent, we can say that there exists no solution for this system of equations. So I hope you have understood it well, and thank you.
Don't forget to like and subscribe.